Hello guys, here is Easy Math to teach you how to prove this problem. So let's do this. First of all, I'm going to define n, which stands for number with n digits, and p, which stands for product of all its digits, as following. Note that the product of all digits of number with n digits is less than or equal to 9 to the power of n. We must show that n is greater than p. Expand the expression of n and p as following. And then, we are going to divide both sides by the right term. After that, I'm going to separate each summand in numerators as an individual summand, but in fractions. And then, we are going to concentrate ourselves at the first summand, 10 to the power of n minus 1 divided by a2 times a3 on and on times an. Now, we are going to prove that the following term is bigger than 1. To prove the first summand is bigger than 1, I'm going to bring the fact that product of all digits of a certain natural number with n digits is less than or equal to 9 to the power of n. Knowing this fact, we also know a2 times a3 on and on times an is less than or equal to 9 to the power of n minus 1, which makes the first summand always bigger than 1. Since the first summand is bigger than 1, and rest of summands are non-negative, we can conclude that the sum of the left term is greater than 1, and therefore this inequality is true. That makes n greater than p, and we prove the statement that any multi-digit natural number is greater than the product of all its digits. But one thing is missing. What about when at least one digit is equal to 0? If at least one digit is 0, this inequality that I used for the proof wouldn't make sense, because you can't divide a number by 0. So, we must use another method for this case. Knowing that the product of a1 times a2 on and on times an is 0, we know that a1 is bigger than 0, and a1 times 10 to the power of n minus 1 is also bigger than 0. Add to both terms a2 times 10 to the power of n minus 1 plus a3 times 10 to the power of n minus 3 plus so on and on plus an times 10 to the power of 0, and we get the following inequality. Considering that all digits except the first digit is bigger than or equal to 0, the right term is therefore bigger than or equal to 0. Simplify these terms, and we also get n is greater than p. Thank you for watching this video, and like if you liked the video, and subscribe for more math contents. Comment for any questions. Stay safe, and goodbye for now.